Hello everyone, welcome to the next tutorial. In this tutorial, we are going to solve some problems based on mesh analysis. Okay, so in the first question, we need to find the value of I. Okay, so let's say using mesh analysis, let's say this is your first mesh and the current flowing from this mesh is your I1. Okay, similarly, let's say the current flowing in this mesh is your I2. Okay, so as you can see from this diagram, I2 will be equal to minus of I. Okay. So on applying KVL in the first mesh, we can say that 5 will be equal to 2 times of I1. It means that I1 will be equal to 2.5 amperes. Okay. So it means that since we can, let's say this node is your A and this is your B. So we can say that the value of the voltage VA or the voltage across 1 ohm resistor will be equal to 2.5 into 1, which is equal to 2.5 volts. Okay. So for second mesh, we can clearly see that the value of the voltage across this 1 ohm resistor, so using the voltage division principle, we can see that the value of VB will be equal to 4 times of the total voltage across the 3 and 4 1 ohm resistor, which is 4 VAB into 1 over 3 plus 1. So which is coming out to be VAB. Okay. So VB will be equal to VAB, which can be rewritten as VAB will be equal to VA minus VB. So we already know the value of the voltage VA is equal to 2.5 volts. On substituting the value of VA in this equation, we can see that 2VB is equal to 2.5 and VB is equal to 1.25 volts. Okay. So the value of the current I, which is flowing from this 1 ohm resistor, will be equal to, so using Ohm's law, we can see that I will be equal to VB upon 1, which is, so I will be equal to 1.25 amperes. So I hope it is clear how we are solving this problem. Okay, so now let's solve the second problem. So in the second problem, we need to find the value of the voltages V1 and V2 of this electrical network. Okay, so as you can see, let's say this is your first mesh and the current flowing in this mesh is, let's say, I1. Okay. Similarly, let's say the current flowing in this mesh is equal to I2. Okay. And the current flowing in this mesh is, let's say, your I3. Okay. Similarly, the current flowing in this mesh is your I4. Okay. So as we can see that the value of I3 will be equal to 40 amperes. Similarly, the value of I4 is equal to 10 amperes. Okay. Also, from this diagram, we can clearly see that I1 minus I4 is equal to 6 amperes. Okay, 6 amperes. It means that on substituting the value of I4 in this equation, we can get the value of I1 to be equal to 6 plus 10. Okay, which is equal to, so I1 will be equal to 16 amperes. Similarly, in this for this current source, we can see that I3 minus I2 is equal to 9 amperes. So it means that the value of I2 will be equal to 40 minus 9, which is equal to your 31 amperes. Okay. So for mesh 1, we can clearly see that the value of the voltage V1 will be equal to the voltage drop across this 2 ohm resistor plus the voltage drop across this 3 ohm resistor. It means that V1 will be equal to 2 times of I1 plus 3 times of I1 minus I2. Okay, because the current flowing in this 3 ohm resistor is the difference of these two currents, I1 and I2. Okay. Okay, so on substituting the value of the currents in this equation, we are getting the value of the voltage V1 equal to 32 minus 45, which is coming out to be your minus 13 volts. Okay, so I hope it is clear. Similarly, we can apply the same principle for mesh 2. Okay, so in order to find the value of 9 ampere, the voltage across 9 ampere current source, we can say that for mesh 2, voltage across 9 ampere will be equal to, since the current is flowing in the opposite direction, so we can say that minus 4i2 minus 3i2 minus i1. Okay, so it means that which is coming out to be, on substituting the value, we are getting minus 124 minus 45, which is equal to minus 169 volts. Okay, so in order to find the value of the voltage V2, we need to apply mesh analysis in this third mesh. Okay, so for mesh 3, we can say that the value of the V2 will be equal to minus of V9, the voltage across 9 ampere current source, plus, since the current flowing, the value of the I3 is already given to us is 40 amperes. It means that it will be I3 into the resistor, which is 1. So it is coming out to be which will be equal to 169 plus 40. So that is coming out to be 209 volts. Okay, so value of the voltage V1 is equal to minus 13 volts, whereas the value of the voltage V2 is equal to 209 volts. Okay, so I hope it is clear how we are solving these problems. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.